All right, in this short video, we're going to learn about the double angle formulas. So here they are. Sine of 2x is equal to 2 sine of x cosine of x. Cosine of 2x can be written in 3 different ways. Cosine squared x minus sine squared x, 2 cosine squared x minus 1, and 1 minus 2 sine squared x. And lastly, tangent of 2x. That's going to be 2 tangent of x, divided by 1 minus tangent of x squared. So we're going to verify the first two. And let's start with sine. Okay, so normally in verify problems, you start with the more complicated side. And I'm going to declare the left side to be more complicated because there's a 2 in the parentheses and you haven't seen that yet. Not that much, so that seems complicated. So here's the trick. Sine of 2x is equal to sine of x plus x. That's the key. Rewrite 2x as x plus x because they're equivalent. Once you do that, now I can apply the sum formula for sine. So recall that the sum formula has the same plus sign, but it has different trig functions. So sine, cosine, and sine, right? So different trig function, but the plus sign stays the same for sine. Then I write the angles in order, sine x, cosine x plus cosine x, sine x. But check this out, sine x times cosine x and cosine x times sine of x, that's the same term. Right? It doesn't matter which order I multiply numbers in. That's called the commutative property of multiplication. So I can rewrite these as sine of x multiplied by cosine of x. This one can be rewritten. It doesn't matter which order I multiply these in. All right, and now I've got 2 of the same term being added together, right? So if you think about this more simply, if you have x plus x, that's 2x. If you have sine x cosine x plus sine x cosine x, that's just 2 sine x cosine x. So we're combining like terms there. And that was what was to be shown. Okay, so the key is rewriting 2x as x plus x. For your next one, verify cosine of 2x equals cosine squared x minus sine squared x. So what I want you to do is pause the video, try it out for yourself. Then when you're done, hit play and you can check how you did. All right, let's see how you did. I hope you remembered the trick. The trick to verify the double angle formulas is to rewrite 2x as the sum, x plus x. So cosine 2x, start on the left-hand side, that's equal to cosine of x plus x. Sine. Then use your cosine sum formula. Recall that the cosine sum formula has the same trig function, cosine, sine, but it has the opposite plus or minus sign. So because this is x plus x, I'm going to rewrite it with subtraction in the middle. Write the angles in order, cosine x minus sine x, And actually, this one's pretty much done because cosine x multiplied by itself is cosine squared x. And same for sine of x multiplied by itself. That's going to be sine squared of x. And that was what was to be shown, so we're done. So I'm going to write my little box there. Now, if you look at the formulas I gave you on the left, you notice that cosine of 2x can be rewritten in 3 different ways. So where do those ways come from exactly? Why do we have that? Sometimes it's more convenient to rewrite it in a different way. So here's what we're going to do. We're going to look at our Pythagorean identity. Right? And if I rewrite it and move the sign squared over to the other side, I can isolate cosine squared of x, and cosine squared of x is equal to 1 minus sine squared of x. That's one way I can rewrite this. It's the same identity, it's just rewritten to isolate cosine squared. I can do the same thing for sine squared of x. So what would that be? If I isolate sine squared of x, starting with this one, move over to cosine, that would be 1 minus cosine squared of x. Okay, so I can rewrite the same identity in two different ways. So let's see how that helps us. So looking at where we finished, cosine squared of x minus sine squared of x. I replace the cosine squared of x with what is equal to, replace it with 1 minus sine squared of x. All right. And not only that, but combine like terms, because I got negative sine squared of x minus sine squared of x. So I can lose these parentheses because I don't have to distribute anything in there. Keep these. Okay, that is another way to rewrite this in an equivalent way. So cosine squared minus sine squared of x, that's equivalent to 1 minus 2 sine squared x. Okay, or if I replace the sine squared, right? This one I replaced cosine squared of x. So let me try replacing sine squared of x on this one so we can see where that comes from. And sine squared of x is equal to 1 minus cosine squared of x. This time the parentheses are important, so don't forget them. When you plug in 1 minus cosine squared of x, you got to distribute the negative sign. So that's going to be cosine squared of x minus 1 plus cosine squared of x. And that's important because now we've got like terms. Cosine squared plus cosine squared of x. That's going to be 2 cosine squared x minus 1. Okay, so these are equivalent ways to write cosine of 2x. There's 3 different ways to write it, and we just proved that true. And the vehicle for that, again, is this Pythagorean identity formula. All right, let's do one example so you can see how this gets used. We're just going to look at trig equations for our class. So let's look at the double angle formula to help us solve this trig equation. And we're only going to solve it, find the solutions between 0 and 2 pi, on the interval 0 to 2 pi. We've got sine of 2x multiplied by sine of x is equal to cosine x. Okay, so write out what jumps out to me is this is sine of 2x. And I know I have a formula for that. Sine of 2x can be rewritten and replaced with 2 sine of x cosine of x. So what I'm going to do is I'm going to replace that with 2 sine of x cosine of x. And that's being multiplied by sine of x. So I still need to include this original sine of x equals sine cosine x. Now, if you remember from a previous problem, we're not allowed to divide by cosine x. We can't divide both sides by that. That's not a mathematically correct move. But something I can do is I'm multiplying all these together. So I can rewrite the left-hand side as 2 sine squared x cosine x. So sine x times sine x is sine squared of x. And then what we have to do is get this side equal to 0. Can't divide by cosine. Let's get it equal to 0. And the only way to do that is by subtracting cosine x from both sides. All right, so that's going to make the right-hand side equal to 0. Not allowed to divide by cosine of x, but we can subtract it to the other side. And these are not like terms, so I'm just going to write them side by side. All right, now, if you're stuck on what to do here, just remember we've got 2 terms. This is our first term, this is our second term, and they have a greatest common factor. They have something in common, cosine x. So I can factor out cosine of x, bring it out. And what I have left over in this first term, I take out cosine of x, That's just 2 sine squared of x minus, and recall this is 1 cosine x. This is the invisible 1 right here. So if I take out the cosine of x, if I factor it out, I still have that 1. Okay, right-hand side equal to 0, factor out the GCF, and then you set each factor equal to 0. So cosine x is a factor. You have to set that equal to 0. This is the 0 product property, and 2 sine squared x minus 1 equals 0. This one's solved for 0. To solve this one for 0, I'm going to add 1 to each side. Divide both sides by 2. So I end up with sine squared x equals 1/2. Now, I need to get rid of this square, so I take the square root on both sides. Running out of board space. Let's go over here. Sine of x, square root of sine squared. The square root undo each other. Left with sine of x equals. Don't forget, when you do square root in an equation, you put a plus or minus on the number side. Square root of 1 is 1. Square root of 2 is just going to be root 2. So that stays the same. And let's rationalize it. Why not? Multiply top and bottom by root 2. 2 over 2. And what do we get? We get sine of x equals plus or minus root 2 over 2. All right, now remember, we're just solving for solutions on 0 to 2 pi. So where is cosine going to be 0? What angle is a cosine of 0 between 0 and 2 pi? Think about your unit circle there. Cosine is the x coordinate. So where is the x coordinate 0? 2 locations, right? There's one right up top. Pi over 2. Right, that has coordinate 0, 1. So cosine will be 0. And we're also going to have 3 pi over 2. This has an x coordinate of 0. So cosine of 3 pi over 2 is 0. The root 2 over 2 angles, those are my pi over 4 angles, and it's plus or minus. So for the next equation, I'm actually going to get 4 solutions out of this one between 0 and 2 pi. And I'll just write the coordinates for the first one. It's root 2 over 2, comma, root 2 over 2. And you can see, oops, that's pi over 4. You can see that the y coordinate is root 2 over 2. All right, and that's going to be the case for all of these. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. All right, so those are 4 solutions to this part of the equation. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, now if you want to tie your solutions up in a neat little bow here, you can write our answer over here in the corner. That one took a lot of space. X equals, I'm just going to make a list. Pi over 2, pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, and last but not least, 7 pi over 4. So this had 6 solutions on the interval 0 to 2 pi. All right, and that is multiple angles, specifically the double angle formula, and that is an equation how to solve it.